Students, this video I will explain about a relationship between angular displacement and linear displacement, angular velocity and linear velocity. For example, here a particle moves in a circular path. Okay, now this is a circular path. Here the position of the particle at the point here x. This is the origin. With respect to origin, this is the radius vector or bar. Radius vector or bar. So the particle is moving in a circular path. So it has a angular displacement as well as it has a linear displacement. At a time t equal to 0 seconds, the body is here. At a time t1 seconds, the body covered some angular displacement. Here it is a theta. The body covered some angular displacement. Next, the body covered the linear displacement. Here px is called as a linear displacement. When a body moves in a circular path, it has a both angular displacement as well as it has a both linear displacement. So here angular displacement angle here angular displacement theta. Angular displacement theta equal arc length by radius by arc length by radius. Arc length by radius. So here theta equal to arc length being taken as a s. S is the arc length. So arc length s by radius is the r. Here linear displacement s equal to r theta. Linear displacement s equal to r theta. When you write the in terms of a magnitude, linear displacement equal to r theta. Radius vector into angular displacement. This is the relationship between S is here where S is a linear displacement. S is a linear displacement. Units is a meters. SI unit is a meter. Next here R is a radius vector. R is a radius vector. Next theta is a displacement. Angular displacement. Theta is a angular displacement. Okay, this gives the S equal to r theta gives the relationship between linear velocity and angular velocity theta. Here, when you differentiate with respect to time, okay, now when you differentiate equation one with respect to time, with respect to time t, with respect to time t, then the equation will becomes ds by dt equal to r is a radius vector is a constant d theta by d ds by dt is nothing but velocity v equal to r velocity v equal to r omega magnitude. Okay, now linear velocity v equal to radius vector into angular velocity. In terms of vector notation, v bar equal to omega cross r bar. V bar equal to omega cross r bar. This is the relationship between linear velocity and angular velocity. Here v bar is a linear velocity. V bar is a linear velocity. Next, omega bar is a angular velocity. Omega bar is a angular velocity. Next, when you differentiate v equal to r omega with respect to time t, this is how we can take in as equation 2. Differentiate differentiate equation d by dt equal to r constant d omega by dt. d omega by dt. Here we can apply d omega by dt. So here d omega by dt is nothing but here dv by dt is nothing but acceleration, tangential acceleration A equal to change in velocity by time. So dv by dt equal to and tangential acceleration at equal to r into d omega by dt but angular acceleration. So this gives the relationship between tangential acceleration and angular acceleration. Tangential acceleration and angular acceleration. So here, it is nothing but tangential acceleration. It is nothing but tangential acceleration. Alpha is nothing but angular acceleration. Angular acceleration. So these two are mutually perpendicular each other. At this point of E here, this is the velocity, linear velocity direction in this. So V bar is the linear velocity direction. Tangential acceleration also same direction. The change in linear velocity direction is the angular linear acceleration direction. Next, angular acceleration direction is the upward. ఇలా ఉంటుంది. Angular acceleration direction ఎలా like parallel to the change in angular velocity. ఈ direction లో angular acceleration ఉంటుంది. Tangential acceleration ఈ direction లో ఉంటుంది. These two are mutually perpendicular each other. So these three are the very important. Okay, now this is the S equal to R theta is the relationship between linear displacement and angular displacement. V equal to R omega in terms of magnitude. V equal to R omega. There V is called the linear velocity. Omega is called as the angular velocity. Linear velocity SI unit to meter per second. Angular velocity SI unit to radian per second. Next, AT equal to R alpha. This gives the relationship between angular acceleration and tangential acceleration. So these three are the relationship very important. Okay, now please once again watch this video, share to your friends, subscribe it. Thank you. So here, when a particle moves in a circular path, it has a both linear displacement as well as an angular displacement. It has a linear velocity as well as the angular velocity. It has a linear acceleration as well as an angular acceleration. Thank you.